we consider the expression x minus 2 times x plus 4, and we note that this expression is 0 if x equals 2, because 2 minus 2 is 0, and it doesn't matter what x plus 4 is. When you multiply it by 0, you're going to get 0. Okay, and then the question was what other value of x would give you 0. And it should be fairly clear, and hopefully you discovered this yourself, and if you didn't discover it, think about it for a second. But it should be clear then that if x is negative 4, that's going to make this term 0, so that when you multiply the two terms again, you get 0. So we can draw a number line to help us visualize what's going on here. And we'll put the point negative 4 and 2 on the number line, indicating the two values of x for which this expression is 0. Now you're asked to pick a number less than negative 4. That would, on the number line, be a number on this side of negative 4, and evaluate this expression for that number. Well, we can let the class choose, and fortunately nobody chose like negative 87,264, which would have been kind of difficult to evaluate in my head. But I chose x equals negative 5, and that's good enough. Okay, if x is negative 5, it's very clear that negative 5 minus 2 is negative 7. Negative 5 plus 4 is negative 1. So we get negative 7 times negative 1, which is 7. And the main question here is we just want to know whether what we get is positive or negative. So we didn't even really have to multiply these out to get 7 to know that it was going to be positive. As soon as we noticed that negative 5 minus 2 is negative, and negative 5 plus 4 is negative, we knew that we had a negative plus a negative, and that was going to have to give us a positive. And if it had been negative 89,000, whatever I said, well, negative 89,000 minus 2 is going to be negative, and negative 89,000 something plus 4 is going to be negative. So we'd still have a negative times a negative. And if all we're interested in is the question of whether this result is negative or positive, we have our answer, and it doesn't matter where we are on this side of negative 4. As soon as x is less than negative 4, this term becomes negative. And even when x is negative 4, this term is negative. So we know we have a negative times a negative from here over. So now we can say that we get the same result, a positive result for any number on the interval from negative infinity to negative 4. Now, pick a number between negative 4 and 2. Somebody conveniently picked 0, and that's always a good one to pick if it lies within the interval that you're looking at. And we get negative 2 times 4 equals negative 8, very straightforward, and that's negative, okay? And it's going to be the same anywhere on negative 4 too. Reason being that the only place this expression can change, the value of this expression can change its value is when x crosses a 0 point, okay? If x crosses negative 4, then the value of this thing can change because x plus 4 is going to change its sign at negative 4 as you move either from here to here or from here to here across negative 4. And x minus 2 will change its sign as you move from here to here or from here to here. If x is less than 2, that's negative. If x is greater than 2, it's positive. Okay, well, whether you completely understand that or not, it's something you want to think about. We conclude that we're going to get the same result anywhere on negative 4 too. Anywhere between here and here, this is going to be negative, and this is going to be positive. So we're going to have negative times positive, giving us a negative. Now pick any x to the right of 2, any x greater than 2. Somebody picked x equals 3. We evaluated it. We got 7. And the key thing that I labeled here is just that 3 minus 2 is 1. That's positive. 3 plus 4 is 7. That's positive. So we get a positive. And the same thing is going to happen for any number greater than 2, because the number is greater than 2, certainly x plus 4 is going to be positive. And now x minus 2 will be positive, giving us a positive. Again, anywhere, any x value between 2 and infinity. This is a very important technique. It's what we use in solving a quadratic inequality. So we can say that this expression is positive on negative infinity, negative 4, union to infinity. That's the union of these two intervals gives you all the points at which this thing is positive. It's negative on negative 2, 4, between negative, I wrote that wrong. It's negative 4, 2. Let me fix that. Okay, now I've got it right. Negative on negative 4, 2. That means that, for example, if we have the inequality x minus 2 times x plus 4 greater than 0, what's the solution? Well, this is greater than 0 on this interval union this interval. Its solution to this inequality is negative infinity, negative 4, union to infinity. And having this inequality, we know to go back and analyze the values of this expression along the number line on intervals that are divided or demarked by the points where one or another of the factors is 0. If we had had the inequality in this form, now this will be coming up, if the inequality is x squared plus 2x minus 8 greater than 0, well, I got that by multiplying these two factors. So we could factor this, and you're familiar with factoring trinomials, so that's not a problem. You might have trouble discovering it, but I don't think you'd have much trouble, especially with just a little refresher. You would factor this into this form so that you could do this analysis and determine where the expression is positive and where it's negative. Again, this would be a quadratic inequality. This is also a quadratic inequality because when you multiply these things out, it is a quadratic expression. So, store that away, but for right now, be sure you understand this analysis. It'll be very helpful to you when we do some quadratic inequalities, and this is a frequent point of difficulty for students.